our keynote session. So I welcome Dr. Nitya Ganeshan, who will take us on a technical deep dive into strategies for optimizing computing at scale. So put your hands together for Dr. Nitya.
Hello, am I audible? Yeah, okay. One second. Let me take this. Yeah, a very good afternoon to everyone. And thanks for the opportunity, Anita B. and especially the coordinators who are reaching out through mail for continuous communication regarding these presentations and everything. And very glad to thank IBM here for giving me the opportunity to and given a right environment as well. Apart from the business task and impacts, presenting this, it's not an easy way, right? So yeah, thanks for IBM as well. With this, yeah, myself, Nitya Ganeshan. So just 2 minutes about myself. I'm from major MTech software engineering. Post I've done PhD in performance analysis of Docker containers, service function chaining, relevant kind of things. So I'm the speaker at many national, international conferences. And to brief about myself, I'm very passionate about research, especially when it comes to performance and compute. Yeah, with this I hold 30 to 40 research papers along with open source articles, and my passion is to give knowledge sharing and getting the insights from the people or whoever it is. Yeah, and with this we'll get into the topic optimizing compute at scale, advanced strategies for efficiency and scalability. Yeah, these are all the agenda. So don't worry, I just try to engage you as well. What do you feel and how this technology, the terms and terminologies we use it in the day-to-day industry. So that is where the slides were targeted. This, each and every slides, right from first till last, it's been like targeted from the basic developers till high professionals, how we use it and how we measure compute at scale. So each and every slides is focused based on my personal experience and how I take my thesis and how I've achieved. So I would say, like in a single sentence, like this performance impact, uh, thesis which I've done, it's reduced network cost by 12%. So I've taken few points and strategies from my thesis, which I've done, and yeah, I've done PhD from IISc, and a few points which I'm working relevant to the performance domain in the daily aspect as well. So that is where the slides were formed. Okay, and with this, moving to the next slide. Yeah, so why do we need compute in the real world? So it's like freezing statement I put to you all. And so when we see like mobile devices by 2027, it increases this much. And where we see more mobility, agility, and we need the speed, the computation power, and everything should be increased, right? So everything we have to reduce it, sorry. So when you see these kind of resources which it is being utilized by the any computation whichever you take, so how do you are going to measure it? See, of course, the performance, I would say always it's neither green or red. It cannot be solved in a single moment, and we cannot reduce the cost as very early or very easier manner. So what are the strategies we fix for each and every terminologies matters a lot. So with this background, so and also bringing back about the traditional middle boxes in the telecom industry, when you say the capital expenditure and operation expenditure increases, and also like we never focus on some, still they use static service function chaining. Service functions, I mean like the middle boxes or network functions. Likewise, how it varies. So that is what I mean actually, where we can see like inefficient resource utilization, and there is no scalability, and we are not looking for any reusability. So we are not reusing the framework or something like that. So these are all the background of the study. With this, and sometimes in earlier, before the container network functions have come, we are using the middle boxes. Say for example, where there is source to destination. So we need to have lot of middle boxes which is not softwareized. So then virtual network functions have come. Then later on, we use containers, correct? So we call those functions again called as container network functions. But again, the question, the real scenario is that, is the compute power being reduced? It's been resources properly being utilized? Are you trying to reduce the cost? That's the impact. Finally, when we develop a product or we come with right framework or strategy, whatever we use, are we reducing it? So these are all questions in our mind. So I think these strategies may help you, which I walk out from different technologies till last. So whichever the technology, we look for scalability and at the same time efficiency as well. So we'll walk you through. The next first thing is like cloud computing and scalability. I'm not going to give definition about cloud or something. So how the scalability is being relevant to cloud? Yes, of course, the cloud, it's scalability in nature. So many have heard about something called OpenStack. So we all think that OpenStack is very heavy. So, but even some organization own their own private OpenStack on their own based on, because OpenStack contains a lot and lot of components, like 45 components and 60 components. But how do we utilize for your own proper own structure to make it more scalable and efficiency? So what are the components cannot be interconnected, can be how we can reutilize that. So we can plan our proper cloud for our own structure. So that brings more scalability. And we should always think that when we are setting up the cloud for the good scalability, I will give you the strategy that when I work with OpenStack, you should be able to see then apart from DevOps, whatever we're using, we should see more than that, what are the tools can be integrated. And always you should see there are different strategy when you think about the power scalability, because this all relevant to APIs, right? So we have to see that API uses what? Is that really this API is needed to connect with other components or not? So how do we enhance that? How do you want to, if you want to remove or something existing, how your existing coding helps to do much better? I'm just giving example as OpenStack, but it can be of any cloud. In this way, the scalability can be improved. That's the first strategy. So the next thing again is distributed computing. Yes, when it comes to distributed computing, we think that, yeah, breaking the task into chunks and grouping together, right? How you distribute it in loads, and finally we enhance that, or we bring it together. That is a distributed. Even when you see in distributed computing, and we all follow the CAP theorem, right? Consistency, availability, and what is that? Last one is partitioning. Partition this one, yeah. They say that in distributed computing, only two things can be satisfied: either concurrency or availability, or the partition tolerance. Any 2 points can be satisfied. If any of the two things are satisfied, then we can say that your environment is scalable in nature, according to my research perspective, which I worked for since 7 years. Again, coming back to the data relevant. So, like when you see, it's whether your data is stateful or you need data to be stateless, or are you going to do it in the batch processing, or you want to categorize in real time, or you're going to categorize it in a large scale, or you're trying to bring in like a streamlined processing. So accordingly, we should choose our methodology. So based on the right methodology and strategy, I would say we can improve the scalability and efficiency in the distributed cloud perspective. So that's one point. And serverless computing, again, so we know like serverless computing, so without relying on the infrastructure, we use it. There's something called serverless containers. So how many of them worked on serverless containers? Yes, serverless containers combines the technology of serverless and containers without worrying about underlying infrastructure. Okay, the example I can give, like Google Cloud Code Engine. Okay, and this, what it does actually is serverless. It does auto scaling. Yes, and complexity wise, it's very better. And many are moving to serverless computing and containers, sorry. So even I work with the OpenShift, so I do performance for OpenShift in IBM. So what we do is that for the, even we do have like serverless operator, okay? So how do we measure performance in our Z perspective? So me Z, I mean in IBM's mainframe. So how do we measure that performance? So we do see that like how different computing strategies we come across. And the second point is that the data structures, everywhere the data structure comes. When you see, I just put the basic things about what is serverless, the people who are from the different background or something. So the slides covered like that actually from the, it should target every audience, so that's why. And also, when you talk about this serverless, the automatic scaling, efficiency, and the main thing is that, yes, when we are using, yeah, Kubernetes can also be integrated. The reason why behind, because I can see a lot of talks relevant to reliability and fault tolerance. Now, the question is that in compute that how well it can able to respond, correct? First thing. The second thing is how my machine, I can say it is fault tolerant. It cannot be 0% fault tolerant. We cannot do that, but it can reduce the percentage. Yes. So that is one thing which we need to consider. And edge computing, yes, many travel from traditional computing, edge computing nowadays. There is a lot and lot of research identification is going on. Even I'm trying to find a patent, file a patent in edge computing. Few things. Along with that, I would say, so how close we are bringing the data. So I no need data from my data center. So I need the relevant data which is near to me, which I can use it for autonomous computing or IoT, especially edge devices, how you connect it. Again, how do efficiency comes there when I use that? Efficiency comes again we have to categorize the data, whether the data from the original source, how do I categorize the data, and how do I process the data? Am I balancing the load? All those things has to be considered as a strategy and methodology when we do it in edge computing perspective. Next thing is, yes, we all know, we all with Kubernetes now, orchestration and containerization, yes, it's fault tolerant. Again, in Kubernetes, many say that it is the one interesting use cases, I would say, the Kubernetes, it's a fault tolerant. Again, they say, but I will not say that it is completely fault tolerant. Again, it depends on replication factors. When you see a lot of containers, they have lot of replication factors. They keep it like 5, 6 or something. After that, what happens? So everything dies. We depend on lot of worker nodes, right? So how many worker nodes I should create it? So when I'm logically partitioning all and each and every nodes, so we have a question that again, so how many nodes I should create for efficient fault tolerant machine? So how do I make my machine efficient? So all these things in our mind, and that is so how we can reduce it further with the help of lot of advanced scheduling mechanisms are there. So that is where many containerizations or many whatever containerization or any computing paradigms, they want to combine modeling techniques like AI, machine learning AI and NLPs, and if you want reinforcement learning, so many modeling has come. But how do we integrate it with our container framework? So are we going to increase the replication factor by 2x, 3x? Am I going to reduce my compute power with that? So without any mathematical analysis, we cannot figure out directly in the large environment. So these all practices needs to be more. We should get more knowledge more on that actually. The next thing is yeah. I can give best example like what are the advanced fault tolerance apart from Kubernetes and everything in the real case. We can see Airbnb and Netflix. There's something tools called in Netflix called Netflix Chaos Monkey. Okay, So this is one of the use cases in one event I got to know. So what they does is just they induce the failures and to see that how well the load can perform. So it's like, yeah, inducing the failures, more failure workloads, or it can be data, something like that. Says by how it can able to automatically can able to it can able to give response. It's all about it's the machine is highly performant. We can say with the user experience, right? So there are these all some strategies we should also think about, and something called sharding. Yeah, sharding is like breaking the problem like it's like a sister of distributed computing, we can tell. Shards, making into small set of units and solving it. Each unit is responsible for each unit has its own head, which can able to take care of the particular scaling unit without disturbing the other nodes or something like that. So even that can be a solution for whatever the irrespective of the environment, whatever it is. And what are the resource optimization techniques and tools which I have worked again is the thing is like different metrics. Yes, when you are dealing with computation and metrics, I would say what is the new metrics you're going to introduce for your own environment. So rather than like response time, throughput, latency. So are you, when you're working with networking, are you bringing some new metrics? And how do we test that in different environments? Say example like topology change detection time or something like that. So I've given one, I cannot reveal it more. Okay, so likewise, we have to introduce a matrix, but at the same time, we have to see that how it works right for our proper environment or not. So that's one thing. The second thing is that solutions from my own perspective, we would say first thing is that you should see any components. If there are 10 components involved in architecture, I would say if you could able to reduce one of the component and combine it with the main component so that you can enhance the performance. That's one solution which we have experienced it. And the third thing is that any modeling techniques using in the different environment can able to solve the performance value, and it can able to reduce the network cost. Finally, so we develop a product, right? So it should, the cost minimization has to be good actually. And the next thing I would say, like later on, the technical, more deep technical, like what is the caching mechanism involved and what is the scheduling mechanism they use it. So all those things, so it's each and everything I'm giving like definitions, a problem, project definitions kind of thing. So these are the things we have to keep in mind when measuring the compute at scale. And yeah, please I'll skip it. And the key takeaways, I would say from my perspective, like seeing 7 8 years in the performance, apart from my research, I would say, uh, how do we give the scalable compute solutions in a dynamic scaling environment? The first thing I would say, it depends on the resource, how we provide, whether the resource is stringent. Are you providing the resource with high priority? Are you giving on it on the demand? Or the resources are kept aside as per the user, we can occupy that. So these all factors determines your performance and the compute power. The second thing is efficiency. So you should choose your technology or environment, whether I'm using edge devices or distributed, or are you using cloud or serverless? Can serverless be, I've given a hint that you can use serverless with containers, which can enhance more performance. Again, containers, serverless, along with some modeling techniques will again, we can improve more performance. So that is one thing. And how well your machine heals. And by that time, you can say your machine is very good in system performance. So this thing we have to this strategy we have to consider. The third thing is resilience and fault tolerance. We have like Kubernetes and replication, so many things. But one point I would like to share here is so 10% of my research work, like multi-region deployment. So we call multi-region as in a region, it may have lot of nodes. I'll put it one region. The second region may have the other nodes with different loads. If if complete region fails, the other region can able to take care. The fault tolerance. It is like a backup of the complete different. But it can able to interact with the other zone as well. Zone, I mean here data center. Yeah. Next thing is, the last thing is the predictive analytics. So that is why I just walk you through from different technology, how the scalability and efficiency be relevant to different technologies and platforms from the basics. Yeah, and I would say the conclusion would be like, first thing is the, whenever I sit for like a personal thing, like for the strategic discussions in the research experts, the first thing they invest in multi-cloud. So I want to work with AWS cloud for sensitive, insensitive information. I want to keep my own private cloud as a open stack for my sensitive information. And how do I differentiate sensitive, insensitive information with different multi-cloud, and how do that multi-cloud communicate and we give a result. So that is one. There is a very big project, and it's about multi-cloud and hybrid cloud till now. That is one static discussions to improve scalability, I would say. The second thing is that incorporate serverless. Yes, so we no need to worry about the underlying infrastructure, right? So we just need application in place. I want to run and see my workloads, how it is performing everything. I would say my better suggestion, as I worked with serverless with containers, go with serverless containers to improve your performance and compute at scale. You can see some values, definitely. Third thing is, yeah, everyone, AI, even yesterday also there was a topic, right? So will AI eat the world? So I think third point is she has given the answer that yes, we should intelligate everything, the modeling techniques, that should be needed. And when the call to action means that when in everything is in place, then the infrastructure. So we can have infrastructure, when proper infrastructure in place, then we are ready to go for the next setup. That's one thing. And the practical guidance, yes, we know these are all like basic case studies like Netflix, Uber, Airbnb, LinkedIn. These are all how they use the different infrastructure for the high scalability and efficiency in real life. How they use different technology and integrate it for the thing. The best practices from the base, I would say from my own perspective, is that start with pilot projects. Start small thing, have some values in mind. We should do simulation before we lay out the large infrastructure. So that's first thing. Second thing is automated deployment. Yeah, we should use a lot of scripts like Ansible deployment, and we should not be always like doing the repetitive procedure which consumes a lot of time, and your the performance or the manual procedure goes long. So we should have a full stop there for automated deployment. Then monitoring, even though we have a lot of monitoring and optimization trainings, tools and everything is up, but we should able to figure it out how we reevaluate it, and we do give the proper remediations. That's more important. Yeah, these are the future trends, and yeah, in computer and optimization. I think, hope I have covered everything. And the final thing is quantum optimization. Sorry, I do have very less, but I just want to give how this quantum optimization. See, as we all know, we think like statistics and the quantum, so everything, large data, how we can able to process the complex large number of data. Even I would say like it depends on eigenvalues. A few things. See, it looks, we have studied mathematics, something like that. So there is a lot of things going on that, and we should move forward. And I have very less contribution towards quantum optimization. Sorry in that part. So these all, I hope it covers everything about the technology and scalability with my own experience. But the only thing is I did not mention the values here and there, so due to confidentiality. Yeah, you have any questions, please go ahead. Thank you. You can find me in LinkedIn, Nitya Ganeshan, Dr. Nitya Ganeshan. Yes. Yeah, please questions. Any questions? Yes.
Session, I just heard the last second half of it, what would you say are the most important real-life use cases to what you've learned and researched?
Sorry, come again. You mean
What would
real
be
use?
good real-life use cases for what you've learned and researched?
The real life use cases, I would say, as I mentioned, like I was targeting the network providers. So to reduce the operational cost. So that's my complete thesis. So during that time, so I was exploring all this technology, combining in a single architecture to combine for network function virtualization, containers, and creating a pipeline, how it executes and making it automated. And all this chain, finally, I would say that this beats the network operator cost reduced by 12%. Yes, and this has been awarded by University of Cambridge, and this my best paper and best presenter. Yes.
Um, Actually, like most of the time, we are,
Yes.
yeah, it's here.
Yes. Yes.
So most of the time, if you see, we go for optimization and things in later part of the life cycle of software development, right? So from your perspective, what do you think from day one of your project start that you should consider for having an optimized solution at the end of the day? Your application behaves in an optimized way and it's scalable as well. The basic stuff that you have to really consider something.
Yes. Yeah. Hope when I'm answering, you can see whether I reached your point or not. Yeah. So in my case, optimization in two real scenarios, I may say. The first thing is that we keep something as global optimum. So until I reach this iteration. Say if I keep like 20 iterations or something like that. So until I reach particular iterations, I may say till this iteration my system is performant. It's performing enough in system performance perspective. Second thing, when you see in infrastructure or underlying whatever the architecture perspective, you have to design, you have to think about your workloads, what you give, and and what kind of data you proceed it for the further optimizations that can be considered. I would say optimization has to start in the mid of the project, not in the earlier phase. So when you see starting, your mind should be in optimization, then we will not undergo the process. So that is why I mentioned in slide that best practices, first thing we should start with pilot kind of thing, like simulation. Then we should reach to the high infrastructure.
Because we go back sometimes to redesign certain
Yes,
things too,
exactly.
so
That
that's
happens. Yeah, it's like I think SDLC. Someone have combined right. That software defined life cycle. It's like a waterfall approach. I would say. Once you get the proper requirements, do it again. Sorry, not waterfall. It's incremental approach. Yes. Yeah. Thank you so much for the opportunity and good audience support as well. Yeah.
Thank you so much. It was an amazing session. So, as a part of token of appreciation from our side, I call upon Arundhati to present token of